Good evening. Welcome to data structure training. Data structure is a way to organize our data and put algorithms to solve real world problems. Data structure is basically a way to organize and summarize our data for our future reference. So, data structure is the way to organize, organize, and summarize our data in computer for future reference, so that it can be used efficiently it is used to organize the data so that we can put algorithms to. It is also used to solve real world real world problems using algorithms. So talking about the types of data structure, so we have, on the very basic level, we have two type of data structure. The very first one is linear data structure. Linear data structure, what does it mean? Linear data structure, as the name is indicating, linear data structure leads to in which in which data is stored in linear stored in linear format in which the data is stored in linear format. So what can be the examples? So examples must be such as array, linked list, queue, stack, dequeue. This type of examples are these are all examples of linear data structure. Talking about non-linear data structure, so non-linear data structure. Non-linear data structure. So non-linear data structure is exactly, as the name is indicating, exactly opposite of linear data structure, in which the data is not stored in a linear format. The data is stored in some hierarchical structure. So examples are trees and graph. So the trees and graph are the examples of non-linear and linear data structures. So moving further with data structure, we must be aware of some three things, such as time complexity, space complexity, and big O notation. So starting with the very first thing, that is time complexity. Time complexity. So what is time complexity? Basically, it is the time taken by algorithm to run in a computer, because in data structure we will create algorithm, we will apply algorithm to solve real world problems. So in order to run our code, what time the code is taking, what is the time taken by the algorithm to run in a computer. So this is basically a time complexity, time taken by algorithm to run in the computer. This is called time complexity. After that, the space complexity. That is space complexity. In space complexity, it is the space taken by your code in computer's memory. So it is the space means the space must be in bits, must be in bytes. The unit of data is the smallest unit of data is bit. So starting from the bit up to zettabyte, up to terabyte, up to gigabyte, and so on and so forth. So the space, it is the space taken by code, space taken by your code in computer's memory, in computer's memory, in computer's memory. That's it. So this is space complexity. Now, what is the representation of this complexity? How do we calculate it? Because this is a measurement. The time can be measured. and the space is also can be measured because it is a data basically. So time and space complexity can be measured in big O notation. And what is big O notation basically? So big O notation is the representation. Big O notation. Big O notation. Big O notation is basically it is the big O notation is the representation of time complexity. Time complexity. Time and space complexity. Time and space complexity. So what does this big O indicates? So here we have three type of measurements. The big O notation, the big O representation can be represented in three ways. First is best case. The time complexity are of three type. That is, first is best case. That second is average case. That is average case, and the third is worst case. So these are all three cases in which time can be measured, time can be represented. How do we calculate it? So starting from the constant time complexity from big O of 1 till big O of n factorial, where n is the number of inputs, n is the input size basically. So big O of 1 is the very this is the very minimum time taken by the computer, taken by the code to run, or taken by the code to take the space. Because if we talk about the space is variable. Space is variable. The code can be of any size, but space, apart from space complexity, time complexity is very important. Why it is important? Because that ultimately how long it is taking to run in your computer, it is very important. So big O of 1 is the time taken by the computer. It is a constant time. That means regardless of irrespective of what is the input size, the code is going to run. The code will be run in the fixed hours, in the fixed time, not specifically hour, because it hours is very such a long time. So big O of log n. Big O of log n. What is big O of log n? So big O of log n, that is a logarithmic. I'll big O of log n is a logarithmic time complexity, and big O of n log n, it is somehow greater than big O of n log n, greater than big O of n. That means number of input. It depends on number of input. Big O of n shows that it depends on the number of input. Uh, Number of input, and after that big O of log n, then we have big O of n minus n raised to 2, n raised to 2, that is big O of n square. That means the input size is if 5, then the time is going to be taken by the code for 25. The 5 square is 25. So big O of n square, then big O of 2n. So 2 raised to n. So 2 raised to n, and after 2 raised to n, it is n factorial. That is, if the input size is n, then n factorial will be the time taken by the computer. So what are the examples? So every thing has its own time complexity, such as if I talk about if. So if has a time complexity. If takes if takes if takes big of one time complexity. If takes big of one time. Talk about else if. So it takes big of log n, and else take big of n square, which is the highest time complexity. Second highest. It is the second highest time complexity. So this is the basics of data structure, that how does it work. Data structure, what we have studied so far, that data structure is the way to organize our data in a computer for a future reference so that it can be used efficiently. It is used to solve real world problems using algorithms. It has two types, and apart from this, time complexity. Thank you so much.